For page 89, please title your notes sequences. And so this is just going to be a bunch of vocabulary that I used in class today and some new vocabulary. And this is going to be on pages 89 and 90 both. Okay, so sequence is a list of numbers or objects in a special order. The order does matter because if you switch the order of any one of them, then you can't get the next term in the sequence because the pattern no longer holds. So here's an example, 3, 5, 7, 9, ... You'll notice I have these little curly brackets around it to represent that it's a sequence. You don't have to have them on there, but if they are on there, that's fine as well. We denote a sequence using a sub n rather than f of x. Again, has those little curly brackets. A sub 1, which in this case is 3, would represent your first term. A sub 2, which in this case is 5, would represent your second term. A sub 3 equals 7, A sub 4 equals 9, and so forth. The ... just simply means the sequence goes on forever, which we call an infinite sequence. Each number or object in the sequence is called a term. A finite sequence is one that the number of terms can be counted, so the terms do not go on forever like that ... that I showed you. An infinite sequence is a sequence whose number of terms has no limits, therefore it cannot be counted. That's where the ... part comes in that I was talking about. When we talk about sequences, they do have a domain. We start with n equals 1, then n equals 2, n equals 3, and so forth. Therefore, your domain is going to be your counting numbers because we call this domain the natural numbers. These are going to be the positions, the first position, the second position, the third position, and so forth. So therefore, we can't have a 1.2 position or a 2.7 position or a square root of 5 position. Therefore, the domain of a sequence is going to be the set of your natural numbers. And then the range of your sequence is going to be the terms that are obtained from a given rule. So if my sequence, the rule was a sub n equals 3n, then for n equals 1, plug in n equals 1, you get out 3. For n equals 2, 3 times 2 is 6. For n equals 3, 3 times 3 is 9, and so forth. So my sequence is 3, 6, 9, 12, and so forth. These are going to be considered the range of your sequence. And then 1, 2, 3, 4 would be considered the domain of your sequence. And the a sub n equals 3n would be considered the rule. That's all I was able to fit on page 89. So I'm going to continue now to page 90. But again, it's just still a bunch of vocabulary. Okay, so I just titled this one Sequences Continued. Now, using that concept of domain and range being the natural numbers in the terms of the sequence, I'm going to take that same sequence, a sub n equals 3n, and I'm going to plot it. So when you're graphing the sequences, the domain was 1, 2, 3, 4, and so forth. Those will be the first numbers in your coordinate. And then the numbers that you get as your terms would be the y values. So in this case, n equals 1 goes with 3, n equals 2 goes with 6, n equals 3 goes with 9, and so forth. So if I go to plot this then, I would plot it just like I would a normal coordinate. The only difference is we do not connect the dots because we can't have those decimals or square roots, irrational numbers, and so forth. So we're not allowed to connect these dots because our domain is only the counting numbers, and that's it. So this would be an example of how you would plot a sequence. Now, I did use the word explicit today in class. We have two types of formulas that give us the rules. One is called explicit. What that means is if I just simply plug in n equals 5 to find the fifth term, or if I plug in n equals 7 to figure out the seventh term, I have a formula that I can use to figure out that term directly. So here's an example of a sequence that's explicit. A sub n equals n squared plus 4. So if I want to figure out the second term, for example, I plug in n equals 2. 2 times 2 is 4. 4 plus 4 is 8. So I now know that the second term is 8. If I want to figure out the fourth term, 4 times 4 is 16. 16 plus 4 is 20. So now I have my fourth term. This allows me to figure out the 100th term, the millionth term, and so forth. This is what's called your explicit formula. Now, your recursive formula is a little bit harder. I haven't talked about this one yet, but I will tomorrow in class. So a recursive formula is one that requires you to compute all of the previous terms in order to find the next one. So what that means is in order to get to the 15th term, a sub 15, in a recursive formula, you would have to have a sub 14, a sub 13, a sub 12, 11, 10, 9, 8, all the way down to a sub 1 in order to get to the 15th term. There's no way for you to just simply plug in n equals 15 into anything to figure out the 15th term. You would need all the previous ones. So here's an example. They would first have to give you a starting point, a sub 1 or a sub 2, a sub 3. They have to tell you one of the terms of the sequence. In this case, a sub 1, or the first term, is equal to 7. A sub n now is equal to twice the previous term. If I take the a sub nth term, and if I go back one, I would call that a sub n minus 1. I'm going to multiply the previous term, a sub n minus 1, by 2, and then I'm going to add 4, and that'll give me the next term of my sequence. So, for example, in this case, in order to find a sub 2, I'm going to plug in 2 into my n here for a sub n, and my n here for a sub n minus 1. 2 minus 1 is 1, so this means take a sub 1, multiply it by 2, add 4, and that'll give you your second term. So 2 times 7, which is a sub 1, is 14, plus 4 is 18. I now know that a sub 2 must be 18. If I continue the same pattern, a sub 3, I'll plug in 3 for my n here and here, which means a sub 3 is equal to 2 times a sub 2 plus 4. Well, I already figured out a sub 2 was 18, so 2 times 18 is 36, plus 4 is 40. I now know that a sub 3 is 40. And I'll do one more. A sub 4 is equal to 2 times a sub 3, that's the a sub n minus 1, plus 4. Well, a sub 3 is 40, so 2 times 40 is 80, plus 4 is 84. And you would continue this pattern up until the point that you want. If I tried to find the 10th term, I would plug in n equals 10 into this a sub n, and then here as well. So that would be a sub 10 is equal to 2 times a sub 9 plus 4. But there's no way for me to calculate that without actually figuring out a sub 9. But if I wanted to figure out a sub 9, I would need to know a sub 8. So there's no way for me to plug in n and get a term directly. So therefore, this is called a recursive formula. For now, this is it for these 2 pages on sequences.